Okay, now let's talk about the atomic number, mass number, and isotopes of atoms or elements. If I gave you an atom, how would you know what kind of atom it is? How does an atom of hydrogen differ from an atom of oxygen? Well, it turns out that the number of protons in an atom's nucleus define which element it is. In this atom, we have 7 protons. We use the term atomic number for the number of protons in an atom. So if you look on the periodic table, for every element, you'll find an integer associated with it and this is the atomic number. The atomic number of nitrogen is 7, so this atom must be nitrogen. Every single atom of nitrogen in the known universe has 7 protons. If you were able to remove a proton, you would no longer have nitrogen. You would have an atom of carbon. The number of protons is the defining characteristic of an element. Well, what about neutrons? Neutrons are needed to stabilize the protons in the nucleus. So the number of neutrons in atoms can vary as long as there are enough neutrons in the nucleus, and that's usually at least 1 for every proton, then the atom can be stable. Neutrons can't be removed in chemistry experiments, but when atoms are created, they can be created with different numbers of neutrons. About 99.6% of all nitrogen atoms have 7 neutrons. About 0.4% of all nitrogen atoms have 8 neutrons. There are other combinations, but they aren't stable. We call these different forms of nitrogen isotopes. They all have 7 protons, but they have different numbers of neutrons. Now let's introduce the mass number. 7 protons in this particle plus 7 neutrons give a total of 14 particles in the nucleus. The number of particles in the nucleus is called the mass number. Because the mass number is specific to each isotope and not to all of the atoms in an element, instead of looking at the periodic table, we often use an atomic symbol to designate a specific isotope of an atom. And here's an example of an atomic symbol for the atom we've been looking at. So we have the element symbol here, nitrogen, N, and down here we'll have the atomic number. Now, many times books or other places will not show the atomic number, and that's because you can look on the periodic table and find the atomic number. The mass number is shown up here, and in our case, this is nitrogen 14, and so it has a mass number of 14. And isotopes are atoms of a specific element that have the same number of neutrons. So there is a nitrogen 14 isotope and there's a nitrogen 15 isotope. Those are the 2 major isotopes of nitrogen. There are others, but they are not stable to any great extent. So, and we call this one nitrogen 14. Now, what about electrons? Well, atoms are neutral. So if we have 7 positive charges from the protons, we must have 7 electrons or 7 negative charges from the electrons. So the number of electrons is equal to the number of protons. Ions, on the other hand, have an uneven amount of electrons and protons. Nitrogen forms the nitride ion. It's a stable ion of nitrogen, and it will have 10 electrons and still 7 protons, or else it wouldn't be nitrogen. So we can figure out the charge on it by taking the number of protons, which in this case is 7, minus the number of electrons, and that's 10. So 7 minus 10 is -3, which is the charge on the nitride ion. And we'll denote the charge up here just where like you would normally see it written. If there is no charge, of course, we're not going to write a 0 up there. So, as a summary, in a neutral atom, the number of protons is equal to the atomic number. And that is the defining characteristic of an element. The number of neutrons is equal to the mass number minus the atomic number. You will either be given the number of neutrons or the mass number if you are given a problem asking you for either one of those. You can calculate one from the other, but you are not expected to know how many neutrons there are in an atom unless you are given the mass number, and vice versa. And then in the neutral atom, the number of electrons equals the number of protons. Now in an ion, still the number of protons equals the atomic number, and the number of neutrons equals the mass number minus the atomic number. The number of electrons, just by rearranging the equation on the previous slide, the number of electrons is equal to the number of protons minus the charge. In the case of the nitride ion, we have 7 protons and a charge of -3. Well, 7 minus -3 is 10. So we would know that we'd have 10 electrons in that atom.